Equilibrium is defined as a point in a reaction when there is no net product being formed, meaning that the concentration and the rate of formation of reactants and products is the same. However, this does not mean that the reaction is stopped because it is still constantly occurring in the system.
K is the equilibrium constant, which is defined as the concentration of the products or the concentration of the reactants at equilibrium. This example shows the concentrations of ammonia over concentrations of nitrogen gas and hydrogen gas, where the coefficients are used as exponents.
The Chatelier's principle is a law that states that any system under equilibrium will adjust to the stress applied to try and re-establish the ratio of the concentration of reactants and products.
In an exothermic reaction, when temperature increases, the reaction will shift towards the reactants. And vice versa, when the temperature decreases, the reaction will shift towards the products. In the diagram, when temperature is increased, more solid is formed.
In an endothermic reaction, heat acts as a reactant, so when temperature increases, there will be a shift towards the products and vice versa.
When volume increases, the reaction will shift to the side with more moles and vice versa. The example shows the shift towards the side with more moles when volume increases.
The shift in the reaction when concentrations are changed depends on what is being added or removed. If product is added, then the shift will be towards the reactants, but when it is removed, there will be a shift towards the products.
Pressure is similar to volume in that shifts depend on the number of moles of reactants and products. When pressure increases, the reaction will shift to the side with the least number of moles, and vice versa. Pressure decreases cause a shift to the side with more moles.
According to the Bronsted-Lowry model, an acid is a proton donor while a base is a proton acceptor. In the base model, HA is the acid because it donates a proton to water, making hydronium an A- ion, while B is a base because it takes an H+ ion from water, leaving behind OH- and Hb+.
The strength of a conjugate acid depends on the strength of the base, and vice versa. A strong base will have a very weak conjugate acid, and a strong acid will have a very weak conjugate base.